We are going to get started, and we are going to do 13 through 24 in this recording. So the first question, number 13 here, we have this dot plot that we saw in the statistics unit. A group of students was trying to determine the proportion of candies in a bag that are blue. The company claims that 24% of the candies are blue. The simulation was run 100 times with a sample size of 50. That 100 just means there's 100 dots in the picture. Based on the premise that 24% of the candies are blue, the approximately normal results of the simulation are shown in the dot plot below. Now, it tells us that it has a mean of 0.254 and it has a standard deviation of 0.060. Where's a plausible interval? The middle 95. The middle 95 is the mean plus or minus 2 standard deviations. Remember, the margin of error is 2 standard deviations. So if we just double that 0.060 number, we get 0.12. So what we're going to do is we're going to add and subtract that on and off of the mean. So 0.254 minus 0.12, type that into your calculator, and we will get 0.134. 0.254 plus 0.12, and in that case we get 0.374. So we just look for those numbers, and that is choice 2. Number 14. Number 14. We have selected values for 2 functions are shown in the table. A solution to the equation, this is a red flag, a huge red flag. They have 2 equations, 2 functions, and they set them equal to each other. They want to know what is the solution to that equation. Remember, when we see that, the question wants the x value of the intersection point. So first thing we want to do is find the intersection point and then just say the x. The intersection point is a point on both graphs. So this point, I don't see it over here. 0, -6, I don't see, because 0, that one. 1.23 is not on that graph. 8.5. Okay, so this I see here. 9.01 is not on that graph. So this is the intersection point, and what it wants is just the x value. Just the x value. And what you notice is you see how 2.53 is there. Do you see how 0 is on both graphs? So they took that one on there. And you can see that 3.01 is on both graphs. So you have to know what they're asking in that case. Number 15, which expression is equivalent to? That just means simplify and compare. Now you can work backwards and try to factor each of your answer choices. That's not the easiest way to do this problem. So I'm just going to write out 3x minus 2i. And remember, I isn't a number. I is the number I. Now what makes this tricky here is that we have a minus in front of the parentheses. 3x minus 2i. The squared means write it out twice. So that 6 minus this product is going to stay in the parentheses because I'm going to have to distribute that negative after. So double distributing, I'll get 9x squared. Negative 6xi minus 6xi is negative 12xi. Now my last term's negative times negative is a positive 4i squared. I suggest you don't do too many steps at once. What I mean by that is now I have an I squared. So now if you want to, you can simplify using your powers of I. 1, -1, I, negative I, and these represent the remainders, remainder 0, remainder 1, remainder 2, or x1 and 2, which is what we have, remainder 3, or you can just memorize the powers of I, that I squared equals negative 1, I to the third power equals negative I to the fourth power equals positive 1. Okay, so going back here, negative 6, we have 9x squared minus 12xi. This is plus 4 times negative 1. When you're taking your final exam, you don't want to rush steps. So I haven't quite looked at the answers yet. I'm just making sure I can get all my math right. Now I'm distributing that negative 1. And I'll have negative 9x squared plus 12xi plus 10. And looking carefully, that is choice 1. Okay, 16 is a built-in word problem that mixes in with another type of question we've done this year. So we have a number. Let's let x equal the number. So we have a number minus 20 times its reciprocal. 20 times its reciprocal. Okay, so we have 20 times, if x is the number, the reciprocal of x is 1 over x equals 8. We have to solve for the number. All right, so let me see what I can do. I'm going to do x minus 20 over x if I just add that or multiply that together. Now I have a variable in the denominator. So what I want to do is make it so I don't have a variable in the denominator. There's a couple of ways to do this question. What I like to do is multiply both sides by the LCD, in which case my only denominator is x, so that's going to be my lowest common denominator. If I multiply both sides by x, I'll get x squared, and x times that fraction, that is going to cancel out, so it's just minus 20. And on the other side, I have 8x. Since you have a quadratic, we need to get it equal to 0. And solve from here. All right, what multiplies to 20 adds up to 8? That's going to be negative 10 and positive 2, which makes sense because if you look at the answers, I had 10s and 2s. So x minus 10 equals 0, x plus 2 equals 0. I don't suggest you bail in the middle and just pick answers because of the different signs. It will be easy to mess those up. So I have a positive 10 and a negative 2. And because you had a fractional equation, remember you ask, am I okay? Are my answers okay? The only thing that x couldn't be would be 0, so we're good. 10 and negative 2 is choice 1. Now there's another way that you can do this, that you can solve this problem, and I'm going to show you. You can skip over this part if you don't want to watch. Alternatively, you can solve this problem. You still have to set up the equation. But if you want to, you can use cross multiplication. So if I move that 20x to the other side and move the 8, so I have x equals 20 over x plus 8, and then move the 8, so I have x minus 8 equals 20 over x. Then you can just think about it as cross multiplying. And the steps from here, you distribute, and the steps would be the same where you have to get it equal to 0. That's an alternative way to continue the problem. Let's go on to number 17. The savings account S has an initial value of 50. That's why 50 is right there. The account grows at 2%. That's why I see that 0.02 compounded n times per year, t, according to the function. Which statement about the account is correct? As the value of n increases, the amount of interest per year decreases. This question is not a think about it question. This question is not something you should just reason through. You should do the math and prove which situation is correct. So what I did when I did this question is I said, well, we're talking about n increasing. And so what's going to happen to the amount of interest? So the amount of interest increasing or decreasing is going to affect, the total amount that you have. So let's just pick some values. Let's say, pick a value of n. Let's go from like 1 to 2 to 3 to 4 and see what happens. And then, so I'm just creating a table to organize my work a little bit. You don't have a ton of space on your final exam, so you have to kind of choose how you write your stuff. All right, as the value of n increases, so let me see what the value is at 1, and then see what happens as I increase it. So if I take this, put a 1 here, and a 1 times t there, what I'm going to do is, because in each case you're going to have 50 and you're going to have that t. So I'm just going to see how the multiplier changes. And if my multiplier gets bigger, then I know my final amount will get bigger. Thus, the interest will increase. So I'm going to keep that 50. I don't really care about that. And that t is going to remain. But if I type that into the calculator, just 1 plus 0.02 divided by 1, hit enter, and then raise it to the first, that's just going to be 1.02. Okay, so that's my baseline. Now we're going to see what happens as n increases. So we'd want to take a bigger number. Now, like I said, the 50 doesn't really matter. So that 50 is just consistent between no matter what n is. But in this case, I'm going to change my n to compounded 2 times a year. And again, what I'm going to do is I'm just going to type in this and see what happens there. So that 50 doesn't matter. So 1 plus 0.02 divided by 2. Hit enter before you raise it to the second power, or you can put parentheses. So what you get is 1.0201. So my multiplier went from 2% to 2.01%. So my interest rate is growing. Therefore, the amount of interest I'm going to get is also growing. So as the value of n increases, the amount of interest per year decreases is not true. It is definitely not choice 1. As the value of n increases, the value of the account approaches this function. What? Okay, that seems a little confusing. So I'm going to keep going on this one. As the value of n decreases to 1, so I'm going from 2 to 1, the amount of interest per year increases. Well, no, we proved that that wasn't true by my diagram. As the value of n increases from this down to 1, the amount of interest isn't going to increase, the amount of interest decreases, so it's not that one. So then the next one, definitely not. As the value of n decreases to 1, the value of the account approaches the function. Well, if we do this and type in 1 minus 0.02, what that would represent is exponential decline or exponential decay, and you don't invest money and lose money, hopefully. And as the value decreases to 1. It's not approaching that. I have it as 1.02. So the answer is choice 2. Let me explain why. As the value of n increases, the value approaches this amount of money. Okay, so let's figure out what that is. In this case, 50, I'm going to leave a little bit of space. 50 e to the 0.02 t. Again, what's not changing is that 50 is still 50 from this one, and the t is still t. So if I do that same thing with my red and just evaluate this, the E button is second divide. The second divide is where E is. Or you could do second ln, and then it gives you the exponent. So it's in two different spots on your calculator. I'm doing second divide and then the caret button, 0.02, and I'm going to hit enter. Now what you can see is that number is 1.02020134. Now what we had was n equals 1 is 1.02, n equals 2 is 1.0201. So let's pick like a bigger number. Let's pick like 10. So I'm going to continue this chart. Let's pick like 10 and see what happens to my function. And we want to see, is it approaching, meaning is it getting closer to that number? So if I take 50 and do 1.1 plus 0.02 divided by 10 to the 10t, and just type in that amount. So again, either you can use parentheses like I'm doing now, or you have to hit enter before you raise it to the 10th power. And I'm getting closer. This is 1.02018. So this number that as n is increasing, I'm getting closer and closer. This number here is getting closer and closer to this number here. So that's why the answer is choice 2. That was not a think about it question. That was a question where you had to plug in numbers and see what was happening. Number 18. Okay, so we have 400 students in the senior class at Oak Creek High School. All the students took the SAT. The distribution of their SAT scores is approximately normal. The number of students who scored within 2 standard deviations of the mean is approximately what? What you're asked here is, do you know the empirical rule? I think that's how you spell empirical. That's what it's asking. The empirical rule says that approximately 68% of whatever, of the data, if it's normally distributed, falls within 1 standard deviation of the mean. It says that approximately 95% of all the data in normally distributed data falls within 2 standard deviations of the mean. And for completeness, it's 99.7% within 3 standard deviations. So the question is asking, do you know that rule? So the number of students who scored within 2 standard deviations of the mean, you have to know that that means that we're looking for 95% of the students of the 400. So you have to just multiply 0.95 times 400. You'll get 380. Now, number 19, there's a long way and the short way. I'm going to do the long way first in case this shows up as a part 2, 3, or 4 question. This is a radical equation. Radical equations are must checks. When you get your answer that's not necessarily an answer, you have to check to see if it's an extraneous root. How you solve a radical equation is you isolate the radical part first, which mine already is, and then you square both sides. So I'll have b squared equals 2b squared minus 64. Now we got to get it equal to 0. And so I'm going to subtract this 1b squared and have a 0 equals just 1b squared minus 64. This is a difference of two perfect squares, so I'll square root each of those. And so I get two answers. B minus 8 equals 0, so B equals 8. B plus 8 equals 0, so B equals negative 8. Now, both of those are not okay. We have to check. These are must check because it's a radical equation. Okay, so I'm going to plug them into the original equation, which is B equals the square root of 2b squared minus 64. Now, it has to work out on your calculator, so I'm going to write this down and then type in this part to it. So square root of 2 times 8 squared minus 64. It equals 8, so I know that that's the answer. It's not choice 4, and it's not choice 1. So the question is, does negative 8 work or not? So I'm going to plug in negative 8. That's 2 times, you need parentheses around that negative 8. So when I type that in, 2 parentheses, negative 8 squared minus 64. Whoops. Minus 64. All right, so if this is going to be a correct answer, when I hit enter on my calculator, it'll say negative 8. However, it says positive 8. That is an extraneous root. Therefore, the only answer that actually works is positive 8. The only time you have to think about that plus or minus when you're square rooting is if you're solving an equation and square rooting. In this case, I was just doing PEMDAS, so that didn't apply. Now, that was the long way. That was the right way to do the problem. But if you were really thinking about it, you could have said, well, I didn't need to do all that. I know my answers are either 8 or negative 8. So all I had to do was do the check part. So you could have just said, well, does 8 work? And just did the check. And then does negative 8 work? And you could have just did the check and see if that worked. So that was a shortcut to that one. All right, number 20. Which table best represents an exponential relationship? Okay, so some stuff you need to know about exponential functions. Exponential functions. The general equation for an exponential function is y equals ab to the x. So if you're going to do an exponential regression, that's the equation that it looks like. And what we know with exponential functions is that there's a common multiplier. So these types of equations are geometric. Geometric functions mean that there's a common ratio, meaning that there's a common multiplier, so that from one value to the next, it's going to multiply by the same number. To find the common ratio, you figure out what do you multiply from one number to get to the next number, and that pattern must be consistent. The formula is the second term divided by the first term. Okay, so we're going to see what do we need to multiply. All right, so for number 1, if we go from 8 to 4, so your common ratio would be second divided by first. Okay, so do I multiply by 1/2 in each case? So you do 4 times 1/2. Yes, then do 2 times 1/2. That works. And then 1 times 1/2. All of those work, so that's why choice 1 is an exponential relationship. What you would have to be careful about is if you look at number 2 or choice 2, you see how it doesn't go up by ones? It goes up, or it goes down by 4s, but your relationship with your y values, it's still going up by ones. This is actually a linear relationship. Now, number 3, choice 3, it does have a pattern to it. The pattern is these are all the perfect squares. Like this is 0 squared, 1 squared, 2 squared, 3 squared, but there's not a common multiplier. And for choice 4, those are all the perfect cubes. All right, number 21. We want to know a sketch of r of x is shown. What is the equation for r of x? Okay, so the first thing I want to do is think about the formula. I know my arrows are going in the same direction, so I know it's going to have an even exponent. The equation is going to be this, r3, and I know it's going to have 4 roots because I have arrows in the same direction, means it has to be an even number, and then also I see that this is a double root because it bounces off. Now, what you have to be careful of, the trick in this, is that one of my roots is negative c. Now, if you put that into the equation up here, that is x minus negative c. That turns into an x plus c. And since that's a double root, that's going to be squared. It's going to happen twice. Now, my other root here is negative b. So when you plug it in, sorry, my neighbors are here. When you plug it in, it's going to be x minus negative b, which would be x plus b. And my last root is a. So it'll be x minus a, which is just x minus a. Whoa, sorry. Which is just, where are we here? Sorry. Which is just x minus a. I hit the home button. All right, so we have an x plus c squared, an x plus b. There we go. Choice 4. But you can see how choice 2 is shiny because you see, ooh, negative c. You see negative c. You know it's a double root. Be careful about going too quickly. All right, now we have, what is this? The temperature in degrees Fahrenheit and times squared during a day in August can be predicted by the function, and we have this sinusoidal function, where x is the number of hours after midnight. X is the number of hours after midnight. Counting time can be hard sometimes. According to this model, the predicted temperature to the nearest degree at 7 p.m. So we have to figure out what are we plugging in for x. So 7 p.m., how many hours after midnight is that? Midnight is 12 a.m. So from 12 a.m. to 12 p.m., this is midnight. Then we'll go to like noon. Lunchtime is 12 p.m. And then to 7 p.m., which is like after dinner. 7 p.m. So this is 12 hours plus another 7 hours. So we're talking about x equals 19. All we have to do is plug 19 into that formula. So we're finding t of 19. So 8 sine of 0.03 times 19 minus 3 plus 74. Now your mode must be in radian mode for this question. So press mode, which is the quit button, make sure radian is highlighted, and then we consider the system of equations. You guys are very good at systems of equations, 3 by 3. It's just a matter of keeping it straight. So how I like to start these is I like to start by labeling A, B, and C, or you can label it 1, 2, and 3. You have to pick any pair of equations and cancel a variable. Then pick a different pair of equations but cancel the same variable. So if I'm going to pick, doesn't matter which pair. Let's see, I want to cancel a variable. Which pair do you want to pick? How about we pick A and C? I'm going to pick A and C. So I'm going to have x plus y minus z equals 6 and negative x plus 4y minus z equals 17. All right, so I'm canceling the x's. Be careful because 1y and 4y is 5y. Negative z minus z is negative 2z. And 6 plus 17 is going to get you 23. Okay, that's my equation, A, B, C, D. Now I am going to pick another pair of equations and eliminate the same variable. So maybe I want to pick B and C. So 2x minus 3y plus 2z equals negative 19, and negative x. Okay, so I'm going to eliminate x again. This time, I do have to multiply that second equation by 2. So I'm just going to come over here. And have 2x, negative 2x, plus 8y minus 2z equals 34. And so now I'll eliminate x again. This is 5y. Oh, look what happens. My z's go away too. That's interesting. So 34 and negative 19 is 15. So I accidentally just solved for y, which is nice. So I have one answer. Let's see what that says. Which number is not in any value? Well, that is a value. Now I can take my y equals 3 and let me plug it back into my D equation. So I know y equals 3. So I can find what z is. Minus 15 from both sides. All right, so I know that my other answer is negative 4. I can cross that one off. And now I just have to find my last answer. So I'm going to take negative 4 and 3 and plug it into x plus y minus z equals 6 to figure out what x is. Y is 3, z is negative 4. Be careful of the double negative. That's 7. All right, so I have my solution, which means that my wrong answer is choice 2. And the last question. All right, 24. Carmen puts $400 into a savings account that earns 6% annually. The amount in her account can be modeled by this. Great, they gave me the equation. Cool. Where T is time in years. Which expression best approximates the amount of money in her account using a weekly? We're converting annually, yearly, to weekly, but it's her same account. So one way of doing this problem is to see, well, let's plug in a value for years because T is still years. So if we do C of T, let me just think about what, I don't know, how much money is in after 3 years. So that would be C of 3, 1.06. Here's one way of doing the problem. So if you type in this, now this is not the intended way to do the problem, but it works. Okay, So in 3 years, she's going to have 476,4064. So we're just going to check each of them and see which one will get me that same value. It's a long number. To the 3. That's 401. So that's not the right choice. That is 401. So let's try the next one. What happened here? Okay, to the T, to the 3. That's 401 as well. It's the same thing. Okay, so now typing in these last two, what you have to make sure is you have to know how your calculator works. So you need to be typing this stuff in as I'm going through it, because when you type in this 52 times T, if you have a TI-83 calculator, you need to put parentheses around 52 times 3 like I did on my calculator. That gives me 478. Now that's close. So if you did that same thing, but didn't put parentheses around that exponent, you are not going to get the right number. 52 times 3. And we can see that this is 476. So my answer is choice 4, but let me get there the right way, the intended way to do this problem. Okay, so what we're going to do is we're going to take this to the T, and we're going to express it in weekly growth rate. So what this says is I can clearly see it's 6% growth annually. Well, let's see what it is in weekly. So to go from years to weeks, 1 week is 1/52nd of a year. So if I do 1/52, these things aren't the same, right? That's clearly not the same thing, but I need to get the same amount of money. In both cases, I got 476. So what you're going to do is you're going to counteract that. If I raise 1.06 to the 52, but then raise that whole thing to the 52, 1/52 and 52 multiplied to +1, which cancels that move out. So type in that number, 1.06, and again, put parentheses around 1 divided by 52. That's going to get you that 1184 number, but you still have a 52T out here. So, and the 400 out here. So that's for 2 reasons why it's choice 4. If this is a multiple choice question, many times you can just plug in a number and match answers, and that works. Okay, stay tuned for the next set of questions.